Next thing I'm going to do is redisplay the section, but I'm going to change the color scale that we're using. So I'm going to go to Display Sections, Display Data and Model Sections, and 3 iterations. And first let's review the color scale that was assigned by the Res2D software. And you'll notice that the top layer is very conductive, starting at 59.8 or about 60 ohm meters. So what I'm going to want to do is I want to change the color scale in order to enhance the variation in that top layer. So I'm going to go to Display Sections, Display Data and Model Sections, and I'm going to do a user-defined contour interval. And right now my contour interval is a log factor of 1.392. I'm going to change that to 1.3. And again, look at that section. And we're starting to see a little bit more detail. We're losing some detail in depth, but what I'm really interested in is seeing more detail at the surface. And you'll notice that that blue area is only going up to about 100 ohm meters. So we're going to vary this considerably. So I'm going to go Display Sections, Display Data and Model Sections again, and user-defined intervals again. And I'm going to take this all the way down to 1.2. And do it again. And now we're starting to pick up more detail on that near surface. And we're going to do that again until we get the amount of detail that I would like. Okay. So now we're picking up much more detail in the near surface area, and we can see that in several of these areas we have moderately resistive or more resistive areas in that first 2 meters. Still very conductive clays laying on top of a much more resistive basement. This type of data, for example, if it were a levee survey, may represent 2 different stages of the building of the levee. In the first stage, it may have been built with a much denser, more consolidated, more highly resistant material. And then in a second stage, we may have had simply the river mud, which is going to be conductive clays laid on top of this. But these areas laying in the green area may represent sandy areas. Now, of course, if you've got a levee and you have topped that levee with a mud layer, you don't want to see those sandy areas, because those sandy areas are going to be the most likely areas for a washout. So I'd like to summarize the process, and let's go back to the OhmMapper software from Geometrics. The basic process is that obviously we first collect the data and then transfer that data to our PC, where we're going to edit the data and process it. We convert the data into GPS positions. which we see here. We look at the raw data and look for spikes or unusual occurrences in this data curve. We then create a depth section along our line. This depth section we can now export to Res 2D, which we've already done. I won't go through that process again, but we can export it out to Res 2D. And we can create resistivity maps that will allow us to view a plan view map at a given depth of exploration. And let's say we want to look at the greatest depth. We look at the third receiver. Mark it, map it, and interpret it.
For more information on the OhmMapper or any of our geometrics products, please contact us.